Look, I'll give it to you straight. If you don't want to watch the whole video, or if you don't really vibe with math-related topics, here is the most interesting application of what I'm about to explain. If you are playing against a Kazuya and you feel like you are guessing wrong on his vortex a lot of the time, or even every time, mathematically, the optimal strategy for you as the defender would be to block mid 5 out of 6 times and of course block low the remaining 6th of the time. This particular combination of distributions or guesses makes it so that no matter how much the Kazuya player is inside your head, he will no longer be able to deal more than 12.9 points of damage per mix-up on average. Again, block mid 5 out of 6 times and block low for the remaining 1 out of 6 times. If you would like to know how I came to the conclusion of these numbers specifically, or if you would like to know how you can get the numbers for different mix-ups like Law or Anna's full crouch mix-ups for example, or even your own character's 50-50s, and if you would like to know how these concepts interact with more mainstream ones like strategy or luck, then stay tuned as we will be talking about all of these topics. In this video, we'll be analyzing mix-ups in Tekken under the lens of game theory using Nash equilibria, operations research using linear programming, and probability using combinatory analysis. As always, I strongly advise you to use the timestamps because we are gonna start from the very basics so as not to leave anyone behind. And when I say the basics, I really mean the very basics, like what is a mix-up, which is a very good starting point. There are lots of types of mix-ups, but let's make it easy on ourselves and let's say there are two types of mix-ups mainly: true 50-50 mix-ups and complex mix-ups, which are just everything else that are not a true 50-50. But if I were to define a true 50-50 mix-up, it would be a situation where the first player, or the attacker, uses one of two options to attack the other player, called the defender. The defender has to guess which option the attacker is going to use and defend accordingly. It's very important to note that for it to be an actual 50-50 mix-up, the defender's options have to beat the attacker's options 1-to-1 and vice versa, meaning if you can step both options on the same timing, or if you can go airborne to minimize damage, or if you have enough frames to interrupt both of the attacker's option, then it is not a true 50-50. So no, Kazuya wave dashing at you in neutral is not a true 50-50 mix-ups, since you can guess mid or low, but you can also step or walk left, or even interrupt, in which case it stops just being about the two options, half sweep and forward 3, but also timing and layers, and so it stops being a true 50-50 mix-up. For complex mix-ups, it would be best to use an example. Let's say Kazuya lands a hit engager, either forward 2 or back 4 or whatever. So now he's +9 and he's free to mix you up with forward 3 and half sweep, except for the fact that the defender is able to sidestep the mid and launch him, which is of course very bad for the Kazuya player. So as counterplay, the Kazuya here can use an electric to catch the defender stepping for a full launch. So now we've gone from the players having 2 options each to 3 options each, and this is an example of a complex mix-up. You might already know this, but there are lots of complex mix-up in this game. Most of what intermediate players complain about and accuse of being forced 50-50s are actually complex mix-ups with 3 or even more options for the defender, so, you know, skill issue on that front. But going back to true 50-50s, if you can't even apply a true 50-50 after being +9 or after using heat smash, then when can you apply a true 50-50 mix-up? Well, mental frames are an option, but they deserve their own video because they are deep enough on their own. So another option is knockdowns, given that the defender stands up. If they stand up either with tech roll or up or back or whatever, then they don't have enough frames for anything, either pressing or stepping or whatever. They are forced to guess between a mid and a low, nothing else, no other option. Either block mid or block low and punish it. Now we can talk about like the math involved in mix-ups. I'll be honest, the name 50-50 mix-up kinda rubs me the wrong way, because it almost implies that it's completely random, you know? Kinda like a coin flip. What's it gonna be? Heads or tails? Mid or low? Like it's completely random. And it's such a reductive and simple way to look at things. So let's see what math and game theory have to say about true 50-50s. If you model the guessing game in Tekken into a table or a matrix, then you can do math on it, right? For the example of Kazuya's wave dash 50-50, the table would look something like this. If he does forward 3 and the defender blocks it, then no one does any damage, so 0. If he does forward 3 and the defender ducks, then he gets launched for 75 damage on average with no walls. So he deals 75 damage, as you can see in the top left, and the defender takes 75 points of damage, so minus 75 for the defender in the bottom right. The attacker's numbers are in the top left, and the defender's numbers are in the bottom right. Moving on, if he does Hell Sweep and the defender blocks mid, then Kazuya gets 31 damage and the defender eats 31 damage. So plus 31 for Kaz and minus 31 for the defender. And finally, if Kazuya does Hell Sweep and the other guy blocks it, then he gets a launch, of course. So 75 damage taken from the Kazuya player's perspective, that's minus 75, and 75 damage dealt from the defender's perspective. So here's the table that we're gonna use to model the situation. Now, what game theory tells us here is that instead of blindly guessing between mid and low, there are certain frequencies with which you can use each option, so a mixed strategy, so that this situation goes from a random guessing game where the opponents might have a read or multiple reads on you, to a game of statistics where the opponents can't get any more damage than what the mix-up is designed to do, which in this particular case is no more than 13 points of damage. Not even, it's like 12.9, and that's nothing, that's less than a low poke. So here's how we get these numbers from this table or this matrix. We're gonna start with the defender's perspective because I think it's more interesting that way. So let's assign frequencies. I am going to hold back with frequency F, and I'm going to hold down back with frequency 1 minus F. Let me explain this sentence. F is a frequency, so it can be 10% of the time, or 20% of the time, or 50% of the time, which is half the time, right? Or even it can be every time, which is 100% of the time, right? So that's what F is. It's a frequency, how often you are going to do something. And 1 minus F is the remainder of the time. So if F is 30%, then 1 minus F is 70%, the rest of the time. If F is 50% of the time, which is half the time, then 1 minus F is the other 50%, or the other half of the time, right? So let's try and read this sentence. Let's say F is 25% of the time. I'm going to hold back, or block mid, 25% of the time, and I'm going to block low, or hold down back, the rest of the time, which is 75% of the time. And our objective from all of this is to find that magical F, that specific frequency, so that whatever the Kazuya uses, it doesn't make any difference. He is indifferent to his two options if we follow our specific frequencies that we are trying to find, right? And we're gonna do that, we're going to find that specific F using the following equation. Let the utility of player 1, so in this example it's the attacker, and more specifically it's the Kazuya player in this example. Let the utility of player 1 from using forward 3 be equal to the utility of player 1, that's the attacker again, from using Hell Sweep. It's self-explanatory really. We want to make it so that the Kazuya player is indifferent between his two options. We want to make it so that it's all the same to him whatever option he uses in the long run. That's why we put an equal sign there. We want the utility that he gains from forward 3 be equal to the utility that he gains from using Hell Sweep, right? And that's what this equation means. From then on, it's very simple math. we have to find the utility of the Kazuya player, or rather the utility that the Kazuya player gets from using forward forward 3. So that's 0 times F, because player 2, or the defender, is going to block forward forward 3 F% of the time, plus 75 times 1 minus F, because player 2 is going to duck and get hit by forward forward 3 at a frequency of 1 minus F. And on the other side of the equation, we do the same thing for the hell sweep this time. So it's 31 times F, because we are going to get hit by the hell sweep F% of the time, since we're stand blocking, right? Minus 75 times 1 minus F. Minus 75 because that's how much damage the Kazuya player takes from getting his hell sweep blocked, and times 1 minus F rather, because that's how often it's going to get blocked. Remember, down back with frequency 1 minus F, right? And then you just solve for F. You solve the equation for F. Middle school math, really. And now we're left with this, F. F is equal to roughly 83%. So how do you read this? This basically means, this sentence means, if you block mid 83% of the time and you block low the remaining 17% of the time, the Kazuya player has no dominant strategy against you. It doesn't matter how random, how safe, how risky he's mixing you up. He's only going to deal a certain amount on average of damage that we are going to find right now. So we said that F is how often you wanna hold back, right? So you're gonna wanna go to the B column, or the back column, right? And multiply the defender's number there by F. So that's 0 times F plus minus 31 times F. And since we said that 1 minus F is how often you wanna hold down back or block low, you're gonna wanna go to the defender's down back column there and multiply each number there by 1 minus F. So it's minus 75 times 1 minus F plus 75 times 1 minus F. And finally, you're gonna wanna divide all of this by 2. So the number that you're left with is how much damage you're going to take on average if you block with these frequencies, which in the case of this mix-up, of Kazuya's 50-50 wave dash mix-up, is around 13 damage. And that's really low if you ask me, which leads me to think that maybe a lot of 50-50s in this game are overrated if they only do this kind of damage on average, like 13 points of damage, which is very low. But I might be wrong, I might be looking at it the wrong way, I don't know. What I do know is that if I'm ever up against a Kazuya player and I feel like I'm guessing wrong a lot, I can default to this strategy of stand guard 5 times, like 5 times for every 1 time I block with down back, and it's going to take the burden of having to consciously guess every time off my shoulders. And if we do the same thing for the attacker from the Kazuya's perspective rather, it's going to look like this. So basically, if you are playing Kazuya, so this time from the attacker's perspective, if you are playing Kazuya and you feel like you are guessing wrong a lot of the time, if the opponent's blocks guesses right a lot, you should do forward 3 60% of the time, and of course you should do hell sweep 40% of the time. And now you mathematically can't lose on damage over a long enough period of time. This is especially useful again if you feel like the defender is guessing right a lot of the time. Forward 3 60% of the time, and hell sweep the low for the remaining 40% of the time. Anyway, if you think that having to do this math for every mix-up you want to find the values for is very tedious, I agree, that's a lot of math, it is. So if you skip to timestamp, I'll be including a website that can do the math for you, among other solutions. But for now, let's talk about the next point, which is complex mix-ups. As I said before, complex mix-ups are mix-ups where there are like 3 options, right? And P1's option A beats P2's option A and B, but P2's option C beats A and C, like P1's options A and C, but it draws with option B, whatever, complex situations. To solve these, we're going to use another method that I won't explain in detail because it's gonna take too much time to explain. But we rely on the Simplex method, which comes from linear programming, which itself comes from the discipline of operations research, which talks rather a lot about optimization problems, so maximizing or minimizing things, among other topics of course. So basically what we are trying to do, or rather what we should be trying to do, is to maximize reward for the attacker and minimize damage taken for the defender. But because we're working with probabilities, it actually flips around and we end up having to minimize the function for the attacker and maximize it for the defender. Anyway, back to Tekken. For complex mix-ups, we're gonna use the example I mentioned before with Kazuya after a heat engager, just to compare a true 50-50 mix-up to a complex mix-up that's kind of similar, you know? It's the same character, it's almost the same moves. So, as we said, when Kazuya hits with a heat engager, he's +9. He can mix you up with forward 3 and hell sweep, but you, the defender, can sidestep the forward 3 and launch him. So to stop you, the defender, from doing that, he can do an electric, which is going to launch you if you try stepping. And so, like, the layers end here pretty much. There is no other viable option to the defender, which is understandable because he's -9, and they end up, both players end up with 3 options each: block mid, block low, or sidestep left for the defender, and forward 3, hell sweep, or electric for the attacker. The first 4 squares of the table, or of the matrix, we've already seen with the true 50-50, and the rest of the table is just how the new options interact with the older ones and each other, right? So sidestep beats forward 3 and loses to hell sweep or electric, as you can see, and electric has a slight edge against stand guard, but it loses to low block and it wins against sidestep, right? It launches sidestep. That's the whole point of integrating it into the mix-up. So this is the table that we are going to use. What you want to do next is use a Simplex calculator of your choice. I'm going to use this one. Its only flaw really is that it rounds up the results up a lot, so you end up losing decimal positions. But other than that, this calculator is pretty good. You can use it too. So here's how you do it from the attacker's perspective. Your amount of options as the attacker is the amount of variables, and the amount of the defender's options is the amount of constraints, right? For the attacker, we try to minimize the objective function, and each variable has a coefficient of 1, always. And then you'll enter each of the defender's options as a constraint. So for back, that's 0, 31, 3. The second constraint, rather, down back, is 75, -75, and -70. And for sidestep, it is -75, 31, 80. And then you get the numbers, the results. So here are the results, and this is how you read them. This value right here is the inverse of the value of the mix-up. So in this case, the value of the mix-up is 1 over 0.4, which is 2.5. I'll come back to it later. And these 3 numbers are how often you should use each option. But first, you have to divide each of them by that first number, by the value of the mix-up, or rather the inverse of the value of the mix-up. So in this example, I should do forward 3, 0.2 over 0.4, that's 50% of the time. I should do hell sweep 0% of the time. That's called a dominated option in game theory, meaning you should never use it mathematically speaking, right? But it's more nuanced than that in Tekken. If the opponent's health is low enough that a hell sweep can kill, it's a good option. If the opponent is standing still and respecting the frames, hell sweep is good. These numbers always assume that both players are perfectly rational. But humans are anything but rational, of course. However, it is undeniable that mathematically, which coincides with a high enough level at Tekken, Health Sweep is a bad option here, so you mostly shouldn't use it. And finally, you should do Electric the other half of the time. That's 0.2 over 0.4, that's 50%. To find the values for the defender, you do the complete opposite of what we did before. Our options are the variables, and the attacker's options are now the constraints. We now try to maximize the objective function, and the constraints become each of the attacker's options. If you do it right, you should find that the value of the mix-up is the same for both players. So if you try to do it and you find that the value of the mix-up is different, like between the first and the second time, you would know that you've made a mistake somewhere. The value of the mix-up should always be the same for both the attacker and the defender. It's just that the defender is going to take that damage and the attacker is going to deal it, right? Let's address the elephant in the room. The value of this mix-up is 2.5. 2.5 points of damage. Statistically, that's how much the Kazuya player is going to get, that's how much damage he is going to deal using this mix-up. And personally, at this point, I say it's not even worth the hassle. Might as well just do like down back 4 or while standing 1+2 or something safer, right? And this is like why I used this example in particular. You can really see how adding options on both sides, both the defender and the attacker, it dilutes the damage of the mix-up, going from 13 damage on the true 50-50 to 2 points of damage on the situation after an engager. So I only get pushed further into thinking rather that mix-ups and mixing your opponents up is not the way to go. You should not focus on winning by mixing the opponent to death. Like, you're much better off focusing on trying to counter-hit the opponents or trying to make them whiff and punish them as a source of damage, or even poking them to death, instead of relying on mix-ups over and over again, especially when you're so close to doing no damage on average like this situation. I will say, not all mix-ups are like this. Anna, for example, in Heat, has an amazing mix-up between Heat full crouch down forward 2, which is the sweep, and full crouch down forward 1 Heat dash for an average of 25 damage, which is okay, like it's a lot of damage. 25 damage is good. Kazuya himself has something similar. It's the same 50-50 as before, except if like there's a wall to the Kazuya's right. So now he can launch you from Hell Sweep, in addition to launching you from forward 3. So these types of mix-ups I can understand. It's good to apply these kinds of mix-ups rather. It's the other, more normal mix-ups that seem lackluster from a mathematical perspective, right? 2.5 damage is nothing. Quick parentheses. You can use the Simplex method to find the values for a true 50-50 mix-up too. So you have 2 variables and 2 constraints, of course, and everything else is basically the same. You minimize the function for the attacker and you maximize it for the defender. And the opponent's options are always the constraint functions. Everything else has a coefficient of 1. And the last part of this video is the probability side of it. Sure, we found the average value of a mix-up, but that's all it really is. It's the average value. You can guess wrong 4 or 5 or even 6 times in a row, it happens. But how often does it happen? That's what we're going to see with combinatory analysis, which is literally just jotting down the different combinations of possible outcomes and doing math on them. Here you have a table. It's from the attacker's perspective, as you can see. Kazuya is applying his vortex 6 times in a row, and the defender is blocking at that special ratio of 5:1. Block mid 5 times, block low 1 time. So it's like a simulation of a Kazuya player mixing the opponents up 6 times. And we have the results on a diagonal line. So either 6 hell sweeps and 1 mid, or 5 hell sweeps, 1 mid, 4 hell sweeps, 2 mids, all the way down to 6 mids, no sweeps. And as you can already see, all the values converge to around 12.9. The only reason we don't have 12.9 on every single square is because like the 5 out of 6 thing is only an approximation. If you were to put together a bigger table with 1,000 lines and 1,000 columns, it would be 12.9 on every square. That's why it's not like the same number everywhere here on this table. Anyway, I made some other tables, one of which is how some people think 50-50s should be guessed, with the defender blocking mid half the time and blocking low the other half of the time, and some other ones that I did with pen and paper, and it basically all points to one thing. Blocking in accordance to the Nash equilibrium is great, it's really good, on the condition that you are better than your opponent, because it offers very little variance. And variance is basically how much the results vary with luck. So the Nash equilibrium obviously offers very little variance. Every square here is fucking 12.9. So let's look at an example. If the attacker does 3 hell sweeps and 3 forward forward 3s, there are only 2 possible outcomes. You either guess right that one time you duck, which is going to happen half the time exactly, in which case you will actually have out-damaged the Kazuya player in his own mix-up, or you guess wrong that one time you duck, in which case he will average 28 points of damage on his mix-ups, and the average of that outcome is 12.9, of course. So back to square one. Going back to variance, I said that having low variance is good if you are better than your opponents, because luck then plays a smaller role in the outcome of the match. And inversely, if you feel like your opponent is better than you, you're actually worse off using that Nash equilibrium because you are lowering the amount of luck involved in the outcome of the match. Luck is good for you if you're worse than your opponents, because luck helps you win more often. So, in 2 sentences, if you think you're better than your opponents, if you feel like they make mistakes or they overextend more than you, use the block rates that the Nash equilibrium gives you. Use the info that I talked about in this video. And then, like using that, you can minimize like the amount of luck that is involved in the match's results. And if you feel like your opponent is better than you should play more random. You should not default to the Nash equilibrium because that minimizes luck. And you want luck, you want chaos to play as big a part as possible in the outcome of the match if you want to win as the weaker player. So let's summarize everything that we talked about in this video really quick. We talked about 2 types of mix-ups, true 50-50 mix-ups and complex mix-ups. We saw how we can use game theory to find a certain probability vector, which is a fancy way to say how often you should block mid or low, or how often you should do the mid or the low, depending on whether you're the defender or the attacker. We also talked about about the value of the mix-up, which is how much damage on average the mix-up does if you follow that specific probability, which, as we've seen, is quite low sometimes. And I'm going to stop here again actually. Another way to look at it is like an unblockable amount of damage that you do every time the mix-up happens. So for Kazuya, that's 13 damage he deals every time he applies the mix-up. It doesn't matter if you guess right or wrong, he still deals an unblockable 13 points of damage, which makes it rather look better, but it's still just 13 points of damage. He's down back for the 17 damage for reference, right? That's more than like the average value of the mix-up. So I'm open to other interpretations of that numbers, of the value of the mix-up. If you have any ideas, about how to read the value of the mix-up, please tell me in the comments below. Anyway, we also saw how you can get the same numbers for a complex mix-up using the Simplex method from linear programming, and learned about dominated options and how they are mathematically obsolete, but how you should still use them, especially if your opponent is not playing rationally or mathematically perfect, right? And finally, we saw how these results interact with luck. The bottom line being, applying this strategy is better for you if you're the better player, since it minimizes the importance of luck rather in the outcome of the match. But if you are the worst player, if you are worse than your opponents, you're better off steering away from these probabilities, these frequencies, and these numbers, and playing more randomly by not following these probabilities, since you want luck to play a bigger role in the outcome of the match. Now, for the big question, can this information make you better at the game? I don't know, and I don't think so yet. Obviously, it can help you choose what moves to use for the mix-up, right? It can help you choose, for example, between two mids you're not sure of to use for the mix-up. For example, personally, I used to think that while standing 1+2 was better for crouch dash mix-ups than for 3 because, like, the difference in damage between the two options overshadows the 10 frame punish you eat on while standing 2, but apparently not. If you run the math, you would see that for 3 is way better than while standing 1+2, like at least 2 times as good as while standing 2. So you can use like the math that way. It's useful in that regard. But if we're talking about a real match scenario, I have no idea if having that mentality of blocking with a certain ratio in mind is useful, because I haven't tried it yet. So I'll keep you guys posted on that. Yeah, shout out to Game Theory Online on YouTube. Their videos were very useful in making this one. Shout out to the people on the Wave Wiki, mainly 6sweetbix. The prior results on there helped me make sure that I'm not straight up just bullshitting, right? And that there is some common sense behind applying this type of math to Tekken. And shout out to you, the viewer, for watching till the end of the video. Like, that's if you're not already asleep by now. I know these types of topics are like horse tranquilizer for some people, so you must have enjoyed the video if you made it this far. Maybe even enough to press the like button and subscribe. Anyways, appreciate it if you do. But yeah, that's about it. You can hit me up on Twitter or Discord, links are in the description if you have any questions about this. If you want to support me while getting better at the game, you can book me for a coaching session on Metafight. The link is also in the description. Don't worry, I won't gaslight you into thinking that you're losing in Tekken because of the math, right? There's so much more simple and effective ways to get better at the game. But yeah, that's all for now. This has been Magician, take care, and have a good one.